Okay, so 6.1, this will be day number 2. In day 2 video, you will see how to convert degrees, minutes, and seconds, which is those of you that use GPS, huge. Degrees, minutes, and seconds, it's how they came up and how invented GPS. So you use it every day. Now it's time to get an understanding of how we use degrees, minutes, and seconds. You will also see some properties of triangles, and we will also look at similar triangles. Okay, so have your thinking caps on. This video might be a little bit longer, depends on how long it takes you for you to grasp the concept. So let's take a look and let's get started. Alright, so degrees, minutes, and seconds. I'm going to kind of explain to you. Degrees are obviously the most general. Minutes get a little bit more focused, and seconds get even a little bit more focused. Okay, so that's how, if you use Google Earth, it's how they get so unbelievably close to where the location of your house is. They use degrees, minutes, and seconds. It's basically a GPS coordinate to get very, very, very accurate with their details from satellite. Okay, so I will tell you that 1 minute is 1/60th of a degree. So think about it. If the degree is the larger, it would make sense that a minute is a fraction of the degree. So 1 minute is 1/60 of a degree. Okay, so think 60 minutes, right? Understand 60 seconds and a minute. I think then you should understand that 1 second is 1/60th of a minute. Okay, so degree is the largest, minute is a fraction of a degree, second is a fraction of a minute. So therefore, if I asked you to go from degrees to seconds, well then that's 1/3600th of a degree. And this might sound like a little bit of gibberish to you, so what I decided to do was show you, take a look at this. Just so you understand how focused it can get, 1 degree is approximately 69.172 miles. So if you travel 1 degree, you're traveling about 69 miles. 1 minute, look at how focused that gets. 1 minute is approximately 1.15 miles, and now 1 second is approximately 100 feet. They go further into like milliseconds and all that other stuff, but for us, for our purposes, degrees, minutes, and seconds is going to be good enough. So if I said to you, we're located, this is how you take a look at this right here. This is what I'm looking at. I read this as 61 degrees, 18 minutes, 45 seconds. Take a look at the labels that you have on there. Look at the label for minutes. Right, see it right there. Look at the label for seconds. So understand 61 degrees, 18 minutes, 45 seconds is what that says. Okay, so I'm asking you basically to just convert that into a decimal. Here's how I do this. So I'm going to take the 61, that's going to be my whole number, plus, now I'm thinking 18 minutes, so I'm going to do 18 over 60, because I know up here 1 minute is 1/60th of a degree, so I take how many minutes and I divide it by 60. And I'm going to take the 45 seconds and I'm going to divide that by 3600 because it's asking me to convert to degrees. And I know that 1 minute is 1/3600th of a degree. Now, all I'm going to do is I'm simply going to type this exactly how I see it in my calculator, making sure that I put parentheses around the fractions, type it exactly how you see it, and you should end up with, okay, 61 degrees, 18 minutes, 45 seconds is equivalent to 61.3125 degrees. Notice I want you to get very, very accurate with these, so if there are 4 decimal places, you should use 4 decimal places. Okay? Alright, what if I asked you to work in reverse? This DMS stands for degrees, minutes, seconds. So now think, I'm giving you this. I want you to convert it back to degrees, minutes, and seconds. So think you're just going to do the inverse. You're going to work in reverse. Instead of dividing, well, now you're going to multiply, right? So let's think about this. I know it's 142 degrees. I know that's going to be my degree measure. Okay, so to convert to minutes, I'm going to take that 0.2075 and I'm going to multiply by 60. Think, over here, I divided by 60, so it would make sense that I do the opposite or the inverse and multiply by 60. Okay, that gives me 12.45. Notice that I took the 12 and I said, voila, those are the minutes. That must mean that this 0.45 are going to be my seconds. So think about this. I know everybody makes their mistake by saying, okay, well, since you multiplied by 60, that means you're going to multiply by 3,600. That's a mistake. Big, big no-no. Why do I not multiply by 3,600? Well, I don't multiply by 3,600 because I'm already in minutes. To go from minutes to seconds, all I have to do is multiply by 60 again. So now I've converted my decimal degree into degrees, minutes, and seconds. 142 degrees, 12 minutes, 27 seconds. Okay, so hopefully not bad so far. Take a look at the next one. Why don't you, I'd say pause the video here, try to do this, maybe see if you can do it on your own. Okay, so number 1, I know I'm going to take, alright, so there's how I'm going to set that up. I'm going to type that exactly how I see it in my calculator, and voila, there it is. Number 2, now to go to degrees, minutes, seconds, 135 degrees, I'm going to do the 0.4 times 60, or the 0.24 times 60, and now I'm going to do the 0.4 times 60, and voila, there is my answer. So hopefully, degrees, minutes, seconds, so far, so good. Let's keep going. Alright, so triangles. Some things that are going to be important to remember. Let's make sure we're all on the same page. I'm going to label this triangle ABC. What I want you to notice is that I labeled the sides lowercase a, lowercase b, and lowercase c. Angles should always be uppercase. Sides should always be lowercase. Always, 100% of the time. So what I want you to also notice, I knew to put side A here because it's opposite angle A. Side B is opposite angle B. Side C is opposite angle C. So its side is always going to be opposite its angle. Okay. Something else I want you to write down so we're all on the same page. Sides, you're going to round always to 2 decimal places, which is the hundredths. Angles, you're always going to round off to 1 decimal place, which is the tenths. Let's make sure we're always on the same page. Sides 2, angles 1. Okay, for number 1, you should already know this. Sum of the angles is 180 degrees. Got it? Those 3 angles need to add up to 180 always. Larger angles are always opposite. Larger sides, right? The larger the angle, the larger the side. The smaller the angle, well then the smaller the side. Okay, so understand that's going to be important to remember as we keep going. Okay, so similar triangles. What I did for you, take a look. I kind of labeled these two triangles. What do we know about similar triangles? Similar. Okay, so some things I know. If triangles are similar, then their corresponding sides are proportional. What does proportional mean? Okay, how do you set up a proportion? Well, I also know in similar triangles that the angles have to be equal. Notice that I wrote angle A has to equal angle D. B has to equal E, and C has to equal F. Okay, so if those angles are equal, then how could we set up some proportions? I gave you some examples. Obviously, there are numerous ways to do this, so take a look. How I could set up a proportion, I could take C over F equal to B over E. Alright, I could also do C over B equivalent to F over E. Think about how else you could set up a proportion. I don't know, A over D is equal to, A over D is equal to C over F, right? I could do that. Just be careful, don't do this. A over D equivalent to F over C, right? If you're going to start by saying A to D, then it has to be C to F. Large to small has to be large to small. Don't mix them up, okay? So, the example that I gave you, take a look. I decided to put two triangles there for you. To estimate the height of a flagpole, Carrie reasons that triangle ABC formed by her height and the shadow must be similar to triangle DEF formed by the flagpole. So I took triangle ABC and I took triangle DEF and I put them there. It says she is 5 feet 6 inches tall. I'm going to convert that. 5 feet 6 inches tall is the same thing as 5.5 feet. It's going to be easier to work as a decimal, so I decided to convert it to a decimal. So I know she is 5.5 and casts a shadow that is 8 feet tall. Remember, shadows are on the ground. Shadows can't be up here, right? So shadows are on the ground. She casts an 8-foot shadow, while the shadow of the flagpole measures 44. How tall is the pole? Okay, so think about this. They're obviously similar triangles. I can set up a proportion. I decided to do 8 over 44, 5.5 over x. Notice I went from small to big triangle. How do you solve a proportion? Well, I think to solve a proportion, all I need to do really is to cross multiply. So I did 8 times x equals, well, 44 times 5.5 is 242. I then solve for x. I get 30.25 feet. Well, you know me. That's not going to be good enough. I want you to convert that back to feet and inches. So 30.25 feet, what is that in feet and inches? Well, you should be saying to yourself, it's 30 feet, 3 inches. How the heck did I get 3 inches? Well, I simply took this 0.25 and I multiplied it by 12. Because 0.25 times 12 is equal to 3. Okay, so hopefully a lot of information in this video. You can see I told you it was going to be a little bit longer. We're at almost 14 and a half minutes. But hopefully degrees, minutes, seconds, some properties of triangles, and similar triangles. Hopefully you're keeping up with me, you're taking good notes, and you're writing all that stuff down. And questions, we'll talk about those and go over those. Okay? Good job.